Atomic structure and chemical bonding. Modern atomic theory. According to modern atomic theory, atoms of an element contain protons, neutrons, and electrons. These atoms can take part in chemical reactions. An atom is the smallest unit of matter that takes part in a chemical reaction. It retains its identity through all physical and chemical changes. According to modern atomic theory, all elements are made up of atoms. Atoms can be created and destroyed. Atoms are divisible into protons, electrons, and neutrons. Atoms of the same element may not be alike. Atoms take part in all chemical reactions. Structure of an atom. An atom consists of a nucleus in the center, where the protons and neutrons reside. Since protons have a positive charge and neutrons don't have any charge, the nucleus has a positive charge. Negatively charged electrons revolve around this nucleus in orbits or shells. The nucleus is extremely small. It is the central part of the atom. The nucleus consists of two main particles, the proton and the neutron. Particles inside the nucleus are collectively called nucleons. The nucleus is rigid and highly dense. The mass of the atom is concentrated in the nucleus. Electrons surround the nucleus. Almost the entire mass of the atom is in the nucleus, made up of protons and neutrons. Subatomic particles. The table illustrates a comparative study of protons, electrons, and neutrons. The protons, electrons, and neutrons present in the atom are collectively called subatomic particles. The number of protons and electrons in an atom are equal. Therefore, the total number of positive charges is equal to the total number of negative charges. And since the neutrons have no charge, the atom is always neutral. The electrons, protons, and neutrons are the most important subatomic particles of an atom. They make up its fundamental structure.
In the nucleus, proton carries a unit positive charge, while the neutrons are neutral.
The electron is a negatively charged particle. The electron is only 1 by 1840 the mass of a proton. It carries the same quantity of electrical charge as a proton, but opposite in sign.
In an atom, the number of electrons equals the number of protons.
Representation of an atom. A represents the mass number and is written as the superscript. Z represents the atomic number and is written as the subscript. X represents the symbol of the element. Mass number is the number of protons and the number of neutrons. A is equal to P plus N. Z is the number of protons in the nucleus of an atom, and it is equal to the number of electrons in an atom of the element. Atomic number of an element is fixed and never varies. Electronic configuration. Electrons revolve around the nucleus in definite orbits called shells. The shells are labeled as K, L, M, N. They are numbered as 1, 2, 3, and 4. They can hold a maximum of 2, 8, 18, and 32 electrons respectively. The outermost shell is called the valence shell. The electrons in a valence shell are called the valence electrons. When the outer electron shell or valence shell has 8 electrons, it is called the octet state. K shell has a maximum capacity of 2 electrons. It is called the duplet. Structure of sodium and chlorine. As shown in the slide, sodium, whose atomic number is 11, has 1 electron in its valence shell. It tries to lose this valence electron and tries to attain the octet state, which is stable. Therefore, sodium behaves as a metal. However, chlorine, which has 7 electrons in its valence shell, has the tendency to attract 1 electron and reach the stable octet state. Therefore, it behaves as a non-metal. Formation of aluminium oxide. Aluminium, whose atomic number is 13, tries to lose its 3 valence electrons to attain the octet state. 2 aluminium atoms lose a total of 6 electrons. Oxygen, whose atomic number is 8, has 6 electrons in the valence shell. It attracts 2 electrons from aluminium and attains the stable octet state. Thus, 3 oxygen atoms attract the 6 electrons lost by 2 aluminium atoms. Difference between properties of electrovalent and covalent compounds. The table shows the differences between the properties of electrovalent or ionic compounds and covalent compounds. Electrovalent compounds are formed when electrons are transferred from one atom to another, as shown in the examples before. Covalent compounds are formed when there is a sharing of electrons by both the atoms. Read through the table carefully.